Hi again. Hi everyone. To all the people who saw me yesterday with Kevalia, I am back again for my first stream here on Global Hack Week. My name is Akshita. I recently joined MLH as a coach, and yeah, I think let's wait for a couple of minutes for a few more people to join in. Hmm. Okay, until everyone joins, let's just have a quick round of introductions in the chat. Where are you all joining from? What time zone? What's your experience with Python? If that's something you'd like to share. I'm joining from India. It's currently 5:30 p.m. here. Yes, we're coding together, and we're making a cute cat run game, or you can call it cat run. Yes, we are going to use sprites, definitely. Can people here give me a quick thumbs up of whether my voice is audible or not? Am I clear? Do I need to speak louder? Thank you so much. Okay, a smiley one says I'm from India and good with competitive Python but can't build anything with it. Hmm, that's not a problem. I think this should be a simple hands-on for you, and you'll be able to follow along very easily. Also, at the end of it, we'll push this to GitHub and share the link here so you all can refer to it. Obviously, let's. I think let's start. I'll share my screen. Okay. All right. Yeah, with my screen sharing on, let's let's start coding. Actually, how many of you code with Python? How many of you made a game with Python before? Yeah, definitely. Okay. Okay. All right. Okay. Shiva says they did not make a game, but they know Python. Kshitiz Rana tried in school. All right. Yeah. So I do have some things pre-made over here. We're going to write only the code, and all of the assets used in this using on the stream have been prepared from before. Credits to the original creator. So we'll be using something like this, a few gold coins. Do I increase the size of my code editor, or is it fine? Hmm. Let's see. Where can we get these? Okay, I'll drop a link um, to where you can get these. Sure, I'll increase the size. I hope it's fine. All right. Yeah. So the inspiration for this game came from. Yeah. Yeah. If you go to this GitHub repo, you can see this is our cute dog, and it runs and hops and stops. So these assets are the ones that we'll be using. If you want to check out the assets used here, they're in this folder. All the layers and all of these have been used from here. The other assets are, yeah, the other assets, the link to those I will again provide in the GitHub repo when we push the code at the end. Okay, I guess let's begin. If you want to check out the layers, here they are. So these are the layers that we'll be using to build our background. All of these things will move at different speeds, and I think it will turn out to be amazing if you sit along. And yes, that is all the layers. The sprite here is this one. It's a cute cat. So yeah, let's start with the Python file. Okay, let's call it main.py. And obviously, the first thing that we'll do is, since this is using PyGame, the first thing we'll do is import PyGame. I'll turn off my Copilot. Okay, right. It's going to give me a problem. Okay, this is this is going to give me a problem. How many of you use Copilot for coding? Let's start again. Hmm. No. Okay, works. We do not want Copilot disturbing us. So yeah, and the first thing you want to do is obviously initialize your PyGame, and let's start with something like very obvious. Keeping screen width at 1440. This is something that I prefer. This goes with my screen width. You can obviously add something else, and we can add screen height at say some 790 or 780 probably. Let's pick 790. Okay. Next, we're going to define our window that comes over here. That is pygame.display dot set mode. And here we'll add our tuple of the screen width and the screen height. All right, is this easy to follow? I will. Yeah, it's a side scroller. So, given this done, let's move ahead and let's start with pygame dot display dot set caption. Let's set the title of our window. If you see, set caption says this will set your title, and let's call it Cat to run. Simply doing run equals to true while run, and let's make the logic for quitting before we start writing the logic for when the game runs. So we want the game to quit when we press the red icon over here, right? For event in PyGame dot event dot get. Right. If you check at dot event, it is a set of Python modules. Oh, I'm so sorry. I'm so sorry. Yeah. Right. So get will take all event types and it will give you a list of events. Now, out of all the events, the event that we are looking at will be uh, when the user wants to quit. Yep, here it is. And when the user wants to quit, we set run to false, or you can even exit the Bible. And here is something we have to do, that is pygame.display.update. And once you're out of the while loop, we'll do pygame.quit. Okay, I'm so sorry. Yeah, quit. This should render a basic window for us. All that we've done is initialize our PyGame module and we are running a simple window with the condition that once the user wants to quit, that they press this button, the game should quit. Let's try running this. Let me make this full screen and bring up the terminal. What code editors do you all like to use? I think VS Code is my favorite one. Okay, let's run Python main.py. And this is a basic blank window, right? The caption here says scatter run, and once we do this, the game exits. That's all that happens right now. Now, next thing that we're going to do is add something visual for us to see. Okay. Yeah. Now what we'll do is we'll add some code to load and probably draw images. Let's shift the code to here. This is done. Okay, let's add something called a font. I'm font.sysfont and we go with Arial. It's a 24. Okay. Now, for all of you asking where do you get your assets from, I think you can simply do a Google search where you can use the keywords called 2D, platformer, parallax, layer, something like that. And yep, there's a ton of links here that will take you to the assets. And there's also a lot of tutorials. There's YouTube videos that you can learn from, and obviously itch.io game assets. So all of these things, yep, see. I mean, I can drop the link to this particular one in the stream. Okay, now that our assets are set, let's go with adding layers. The one that we saw in the doggo run, I guess. Let's add layers now. Now, let's define a layer list object. Okay. This list will contain all our layers for I in range. Let me check how many layers we have. we have, okay, 12 layers. So for I in range 0 to 12. This is because I have prepared 12 layers over here, 0 to 11. So we're going to loop over this range. And let's write a quick script to layer list or append. And we'll add these. Now in PyGame, whenever you want an image to show up, you have to do pygame.image.load. And now the catch here is all our layers are named very similarly, L0, L1, L2, L3, and that will help us here in navigating through the loop. So our folder is called layers and our images start in this manner. We use an F string and we write I over here, right? And this ends with layers l1.png. So it'll loop over this, it'll add all of these layer images, the path of these images to this layer list, right? And then we can also set something called, I think, okay. Now that we have all of this in our layer list, let's go add layers. Try in layer list, define our window object dot lit. Now, is Blit here is basically the function that you use to render objects on different coordinates. Okay, so this is the object and this is the exact coordinate from the top left that we want to render the object on. So I think this should kind of work, and we're doing pygame.display.update. Let's try running it if that's not a problem. Yep, you see, we have all our layers set up here. We started from this, right? And currently we have this. However, this is our window width. If I decrease the width and probably run the program again, you'll be able to see better. Let's decrease the width to, let's do 1 to 4.8. Run this again. Yeah, now you can see. This is the window, and our layers are just kind of stacked on the right because window dot blit, this starts rendering images from the top left. What we can do here is add something called uh, background width, I get. Okay, so for this thing here, we can do background width is equal to layer list 0, the first element, dot get width. Okay. This is correct. Just let me refer. Does this change anything? Nope, it is not. Okay. Hmm. Okay, I don't think this does anything. Well, let's fix this then. What we can do here is let's why does it not? Okay, we need to fill this empty space. Okay, I think where's the background width go? Right. Now, to fill the whole window, what we have to do is we have to, kind of repeat this image over here. Now, this image is of particular width, and we need to paste this entire image, say just any image of this layer, and we need to repeat it over here. How do we do that? We use something called uh, tiling in PyGame. And how do you do? We take the number of images we need to draw at a given time per layer, and we fill the whole window. Let's see how that works. We do math.ceil and drop. Okay, need to import math and screen height, screen width divided by background width, and we add plus one to it. Okay. Now, once this is filled, we also need the layers to be moving. If you understand, if I go to that game, uh, yep. If you look at this game, I have used the same assets. If you clearly see that the layers in front, they're moving the fastest, and the layers at the back, they're moving very slow. So each layer that is stacked on top of each other, the velocity increases as you come in front. Again, the layers at the back, they're moving relatively slower, and the layers in the front are moving faster than those at the back. So this gives a parallax effect kind of, and yeah, let's try to implement parallax here. Oops. Okay, for parallax, let's make layer scroll velocities, and we could hard code these. Let's say the first layer goes 0, second goes at 0.1, third goes at 0.2, 0.25, say 0.3, and 0.35, 0.4, okay, 0.5, 0.7, 0.8, and 1. Let's also say 1 again, probably 0.9, and 1. Cool. Now we have all the velocities of the layers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing one. 1, 2, 3. Okay, I think I missed out on one. Let's say zero point 0.6 and 1.7. Cool. Now we have 12 velocities to add to each layer. And let's take a variable called L, and let's take the max of L as 8. This is the initial velocity, and this is the max velocity. Now, before we run this now, let's make sure our layers are put on properly. Now, all this parallax effect will be done by, say, a draw layer function. Okay. Right. So if we go for IM range, say tiles, Yeah, let's this. Prime range styles, we can go and render our images. Okay, need to accept an image here. And we also need to accept, I think, the background width of the image. Okay. We need image and we need some other variables, say x and y. Okay. Let's call x our um, scroll variable and let's call y our speed modifier. Okay. So now we render this image and we render the background width into y plus um, x. Now, this is some equation that I picked up from again the repository that I referred, and this works perfectly for rendering the parallax effect. I hope I dropped a link to the repo, and you can refer to the same equation there. Yeah, um, even this works. Okay, now we decrease our scroll variable by velocity into our speed modifier. Okay, so now what are we doing over here exactly? We are kind of resetting our scroll. So our scroll needs to decrease. This x needs to decrease. Background width into I plus x. This image needs to go back, right? Or if you're seeing on the other side of the screen, each layer needs to move to the left. When they move to the left, that's how you kind of get the effect of the layer is moving. So when they need to move to the left, we need to decrease their coordinates by a certain velocity, and that's what exactly what we're doing here. So if I add a comment here, decreasing x coordinate to make them appear moving. Okay. Now let's check if now there will be a point when this particular x, okay, so when this x uh, it exceeds the background width. Now since this will go in negative. Now suppose this image has been scrolled by its background width. There will be nothing on the screen now. Okay. So what we need to do is we need to reset our scroll. Once this is scrolled fully, we need to reset the scroll. Again, it's scrolled fully and we'll reset the scroll. So once that is done, we reset scroll, and if x is greater than equals to our background width, what do? We set x to 0. Or wait, not x. We need to, since x will go negative, we need to put it in absolute. Right. And then here we return x. So draw layer function, it will be responsible for rendering our layer and also for moving our layer at the back. Okay. Now with this done, let's go back to our while loop and here. Okay. Here we need to draw layers. We were earlier putting all our layers on top of each other, but now what we'll do is we'll assign this that task to draw layer function since we are rendering our image over here. So let's using draw layer function. When this is done, we do for I in range our length of layer list. Again, we can use to 12. You know what? Layer list is 12. For I in range 12, we go with, we have a scroll variable first. No, we do not. Okay, let's scroll is equals to dollar, and what we pass to it will be layer list. Yeah, eighth element of our layer list. So let's just try with this. Okay, to draw layer, we need to pass our scroll variable and our speed modifier. So for the scroll variable, um, let's kind of create a dictionary. We have layer scroll velocities, and let's also create a scroll dictionary. Sorry, scroll list. Fine. So this is an empty list. We'll fill it right now. Let's say scroll I is equals to draw layer, and then we pass in your scroll I, and then we pass our velocities. Yep. Fine. Okay. I'm so sorry I got totally driven away. Yep. Okay. That being done, let's try run this. Will it render? So closing this. Okay. I think we have an error that says list index out of range. Okay. Why does it say that? Okay, I think yeah, got it. I think our scroll isn't defined. Let's say we define it as an empty list. Okay, I hope you all can see that this is beginning to work, right? So the forward layers are moving a bit faster than the backward layers because that's how we decided to be. Now we can probably increase the speed and decrease these. Let's play around with a few of them. I think let's make this zero point 0.7. Let's make this 1. See some improvement. Yeah, now it's much more clear. Again, this animation is not very smooth because each time this image is being rendered, right? As soon as we pass this, this is going to, yeah, this is going to uh, change our scroll velocity, and it's going to render the image to the left, shift the image to the left. That gives us the illusion of that this is a parallax or things are moving over here. Now, let's get this closer to how it looks here. This is at rest over here, and it only moves when we move our sprite or when we press some keys, right? How do we achieve this? Let's come back to the code, and yeah, let's look at this. Now remember we put velocity 1 and max velocity 8. Yep, let's try using this. Okay, we come back to a while loop and we try to stabilize the layers, or and if keys of PyGame. Okay, right. Okay, When we press the right key, that's when we want our layers to move. If velocity is less than max velocity, we want the velocity to become max velocity. Right. Else, if else if no. Okay. Right. If velocity is greater than zero, velocity is equal to zero. And where will we get the keys variable from? Let's get the keys from PyGame dot um, dot key dot get pressed. This will store all the keystrokes, and if there is a keystroke that says keys right, we fiddle with our velocities. Okay, let's see how this goes. Something changed. Okay, now the layers are stable. If I move to the right, you can see them moving. If I keep pressing right, you see the difference in speeds of each of these layers, right? I stop the key press, it does not move anymore. Again, with each key press, it kind of moves. Okay, I think this has been added. Now, there's still a bit of, it's still a bit, what do I say? It's still kind of broken in the middle. Like, you can feel that each image is being rendered. Like, you do not feel it as smooth. What I think there's a small change we can make. Um, right. Okay. When you're rendering the image over here, what we can do is, um, when we're loading the layers, what we can do is we can convert this image and convert alpha. Okay. Sorry. Yep. And now let's try running it. This small change should have made a huge difference. And if you press the right key, see, smooth. This looks very similar to our Dogora. Now, next is next what we'll do is we'll add our sprite, and that is this thing over here. We'll add this. Let's exit this out. Okay, adding sprite. Fine. So for sprite, let's define a function. Def draw sprite, similar to draw layers, and inside this, what are we gonna do? But before this, like we had our layers list, let's have our sprite list. In the sprite list, let's copy this code and paste it. For our sprite, I think, okay, sprite walk list. Let's break it into two, and then we can have sprite idle list. That is different because when we are making our character walk, we need to render it differently. When it's standing, it needs to be rendered differently. So let's edit these codes now. This is 0 to 7, so this will be 8, and this will be 8 as well. Fine. And instead of writing this, we'll, this is idleup.png. Let's paste it over here. Okay, so idle up underscore ri dot png, and this resides in sprite. Again, similar stuff here, and instead of idle up, we write walk. So walk 0.png, and we convert all of them to alpha because we know this smoothens things out. So we have our sprite walk list and our sprite idle list, and we have all of them loaded up. Okay, fine. Now we can make a collective sprite list, and we can have our sprite walk list, and we can have sprite idle list. Okay, why is this? I'm so sorry, I defined it inside the function. Okay. This is our final list of sprite images. Okay, now let's go ahead and draw the sprite. So similar to this, I think we need an image and we need some other variables. Let's see what. So we start with image and we write our usual windows.lit to render it, and we render our image. And when we render image, we'll also need some positioning, which is x and y. And this positioning will come from, let's say, position over here. And again, position is a tuple with x and y coordinates. Right, so x comma y equals to position. We render x and y, and let's try running this and see if we can see our sprite. Oh wait, we need to add it over here also in our while loop. So layers being done, sprite using dot right. Or sprite, and then we can pass that sprite list. Wait. Hmm. Let's store the sprite inside here only. And we get our sprite list. And okay, so now inside this I variable, we cannot go by I because this thing, this will have different indexes. So for this, let's have a sprite index and let's set it to 0. Okay. So inside the sprite list, let's have a sprite index, and we need to change this index every time. So let's sprite index that's equals to 1 for now. For now. Or wait, let's not do anything and let's see if this runs. Okay, we have an error which is Draw sprite missing one required positional argument, which is position. Okay, so our draw sprite function also needs the position. Let's give it that. Let's say I want to position sprite at, say, 100, 100, and check with this. Okay, there's a right. Argument 1 must be pygame.surface.surface not list. Let's fix this. For sprite position, let's also define a sprite position. The sprite position should, let's keep it a tuple of, again, let 100, 100, and passing it here. Let's pygame one free surface dot surface not list. Hmm. What did I do wrong here? X comma y. This should hold. There's something gone wrong with this. Um, can you figure out what the issue might be? Am I going wrong somewhere? What if we hardcode this with this current one? Nope, it does not. And probably gives the same error. Yes. Let's run it. Okay, I think we made some mistake. What's going on in the chat? Oh, somebody's saying you might want to use ChatGPT to debug. Cappy says you are passing a list of images in the draw sprite instead of image. Okay, let's see. I'm passing a list of images instead of draw sprite. But again, I'm passing sprite list and sprite index. Am I not? Okay. I think. Where did it go? Yeah, sprite list is a list of list. And okay, I think This is where the problem is. Sprite list 0. Now let me try. It's still a problem. What is the issue? Sprite list and sprite index. If I try to run this, let's save this. Um, I have no clue what I'm doing right now. What's gone wrong here? Okay, let me print out sprite list, figure out what's happening, and sprite index. So let's run this, and we should have our. Okay, so this is empty. This is empty. Is this not loading? Right, so this is the problem, I guess. But why? Let's position this on top. So we're sure we're not missing out on something. Okay, sprite walk underscore 1.png, idle up underscore 1.png. Where is the problem again? Oh, argument 1 must be. Okay, so this must be surface and not list. We're saying this is a list, and we still have empty. We are empty over here. Why is it so? You use layer list while loading the sprite. Um. Oh my god. Oh my goodness. Yep. Thank you so much. Sprite work list. Right. Sprite idle list. Okay. Should work. Should work. No. Did not. Did not. Why it did not work? All right. Now I know. Now I know. Now this should be 0. Okay. Please work. Fine. Okay. So we have our sprite on the screen. It's a bit off positioned right now. We can position it below. So it was 100 on 100. Let's place it 100 and 250 maybe. Okay. Where's the position gone? Okay, let's place it at 100 and 250. And also, if I can reduce this by say 80. 80 and 250, and the sprite isn't moving exactly yet. Also, before that, let's try this. Oh, it did not change. Why? We hard coded this. No way. I, it did come down. It did come down. Again, I think 80 and 450. Let's just a bit off. Let's do 480. Cool, it's on the ground. But again, this is not moving. Like we have our sprite animations, we have various animations, and it should be working. Like when we press the key, it should be working. So let's go back to our while loop and change a few things here. So if I press the right key, I want the sprite to work. It's not working right now, it's just floating in the air. Let's close this and yep, let's change some things here. So when we do this, we want our sprite index. How are we picking this? We're just picking from the walk thing. Okay, so when we press the right key, let's okay, and take another variable called steps equals to 0. Fine. Okay, so when we press the right key, we want our sprite index to change. When we press the right key, we want our sprite index to change, which is we want to pick the walking list. And sprite index will be decided by that. The steps. So at each layer change, if steps is greater than, say, what was our sprite? If steps is greater than 8, 7. Steps is greater than 7, steps equals to 0. And let's try this out. See, we are moving. But yeah, I forgot to steps plus equals to 1. And OMG, this is okay. Let's fix this. Let's fix this. The cat is vibrating right now. Okay. Um, we can fix this by hmm. So what are we doing here? For infinite number of times this loop will run and this will happen. On every key press, let's do this from here. And on every key press, let's put this here. If steps is greater than 7, steps equals to 0. And for every key press, we just want our steps to increase. Steps plus equals to 1. Let's see what happens. This is okay. This seems to be moving, but there's something wrong with this still. Got it. Hmm. What can we do to change this? I think we should make this a little smooth. This is moving, but this is not the best thing that we can do. And again, these are standing animations. Where's walking? It is walking, but we can't see it. Okay, let's fix this. Where do we edit it? I think instead of going unit wise, hmm, let's make another index variable. Let's call it sprite animation index with 0, and um, we can play with this. So while we are, instead of sprite index, what if we write sprite animation index? And how do we change animation index exactly? So we're not returning anything from draw sprite. Let's return something. Okay. How do we set sprite animation index equals to? What if we do 1 by, do we have a speed factor there? No, let's do 1 by velocity. And when we do this, we need to round it off. So what we can do is math.floor math.floor. Let's see if this changes anything. Nope, nope, broke. Division by 0. Okay. If velocity equals to 0, else 0. Now let's check. Okay, now this is stable. And we can even see our sprite moving. See? We can see it running. We can see the steps. It's taking small, small steps, and we can see those. Fine. However, if the sprite is standing, if you notice, there's we do not see any animation. But we do have animation. See, the tail is moving up and down. The ears are moving. The tail is moving straight. Let's fix this quickly. Um, okay, so I think when it's here, the steps should move and the animation. The steps will remain constant from here. How do we make this move? How do we add static standing animation? With standing here, we need it to load. Hmm. Wait a second. Um, Write in X and instead of this. Okay. How does it change? No, it becomes dead. Definitely becomes dead. I I, I really like this. Anyway, let's not get distracted and continue. Okay. Given this, now like next thing should be we want our character to jump a bit. Like I wanted to jump from here to here, or when I press the up arrow key, I wanted to jump. Let's add a condition. Okay. Now here we are getting all the key presses already. This side, right, arrow key movement. Fine, this is. Okay. PyGame.kwrite. Instead of kwrite, we can look at k. Yeah. And when we do this, we would want. Okay, so our sprite position is this. Instead of defining it here, let's define it in our while loop. And if the up key goes, we want our sprite position to change from 8482. What was it? I think 350. Let's still do 350 and let's check this out. Does it work? So front is working. No. Top jump is still not working. Let's fix this. Take this away from here. Paste it back here. And in the PF, let's add an else and back to number. Okay, so this is very, very, very abrupt. This is jumping, but not the smooth jump that we have. Hmm. Okay. Um, we do not want it to jump abruptly. How do we? Uh, Let's okay. What we can do here is we can have a variable called jump, and let's put jump to 0. If we press the key, then jump to 0, and let's put the y coordinate. Hmm, I'm not sure how we move forward from this. It is jumping. We don't want it to jump like this. We want a nice jump. We add a delay in the jump. Okay, I think. How about we make it jump forward? It looks like it's just hopping. Right, right. How do we make it jump forward? Can we? Should we change the sprite position to I think 90? Let's try this. It is definitely going up, like forward, but slant. Hmm. What next? The horizontal velocity is relative. I don't understand. It's still hopping. How do we smooth this out? Okay. Well, I think we do not have much time left. So before we smooth this out, let's add our coins in. Okay. And we'll work on that soon. So for the coins, let's again go back here and we'll have a def for coins. And we'll have an image and let's form the coin at random positions. Okay, we have windows got lit and we do an image. Along with that, we need a position. Okay, import random. Then we import random and come back here. Hmm. We need to keep it on the horizontal axis, which was uh, 80. Sorry, 480. So our x will be 480, and our y will be random. And we'll give this 80 plus something. Yeah. Oh, no, 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 480, definitely 480 minus. And for this, we could give it an 80 plus random dot random, but again within, say, 50. This to 50. And so we get x comma y. Okay. Looks like this should render our coin image at some random x comma y, which will be some random variables ahead and some random pixels above our sprite. So, yeah, for the coin, we do similar stuff and we get our coins and we can add coin list. Let's try with a simple coin first. Coin equals to pygame dot image dot load, and we can load coins. Let's start with cold 0.png. Coin slash cold 0.png. Alright. And obviously we'll not forget to do a convert alpha because we saw how nice that is. Fine, that is. Okay. Let's try this out. In our while loop we add our coin as well. For coin, and we give coin. Let's see what happens. We have an error, and the error says random.arguments takes no arguments. Okay, did I do something wrong with random.random? How does random work? Random.random. Right. Let's check out something. Float number between 0 and 1. I cannot. Like we can multiply this by 50. Now let's try this. Okay. Okay. Yeah. I totally get it. End this and come, let's fix it. So, wow, that's a cool effect. Again, see, Control C. Let's end this. Let's see what we can do. Instead of defining a def draw coin, let's try defining a class coin, right? And let's define a lot of things inside this. For init, we'll have self.image equals to image. Let's, instead of putting it here, let's pick this up here and drop here. Okay. Once self.image is done, we'll also need self.x coordinate, x, and we need self.y coordinate. Sorry, self.y would be y. We can just let it be 0. Fine. do a draw point, and inside this, let's do windows dot lit, and we have self dot image, and we have self dot x and self dot y. Should be enough. We also want the coin to move along with our layers. Move coin. We want the coin to move alongside layers. This what we can do is self. What did we do with the layers? The layers we subtracted their uh, velocities. So we'll do the same with this self dot x minus equals to velocity. Okay, so that the coin also shifts to the left if the cat misses it. Okay, that being done, how okay, okay, okay. Let's define a coins list to store all coins that we have. And okay, now for the coins, what we can do is we want to spawn the coins. Let's add a spawn delay and keep it say 3000 milliseconds. Okay. And this is done. Um, okay, instead of 0 and 0, let's what did we have with our random function again? Random selection from the given sequence, random element from the given sequence. I think this is the function we'll need. Yes. Okay, let's give it some random dot choice. Let's give it a list of what do we give? What do we give? I think 80. So let's give 100, 150, 200. What's the screen width? The screen width is 1248. 250. Instead of giving 100, let's start from 200. Keep it a little far. 250. Let's give it 300, 350, 450, 500, 700. Okay. And with Y, we have paste this over here and remove 800. 700. Fine. Now, let's go. An object and call coin dot draw coin. Draw coin will have image and X. When we want to move to the right, let's also move our coin. Coin dot move coin. And let's check if this works. Nope. No, there are too many coins still. Okay. Why are there too many coins here? I just need one. Okay, I get it. I get it. I get it. So spawn delay is 300. We need to add some delay over here so that this does not get called every time. Let's figure out something. Okay. Let's see. Um, let's get a time right now. Current time. PyGame time. Uh, Epics. This is how you get the current time. And let's put this inside and it blur. Okay. It's current time means um last spawn. Last spawn is 0. Current time minus last spawn is greater than our spawn delay. Okay. Then we want to throw our coin. We want to move our coin. And we also want to update last spawn time. Okay, let's delete this from here and see. There is no coin. Okay, there's absolutely no coin in it. How do we get a coin? Current time is fine. Okay, Odin even out says something. Actually, when we're jumping and moving forward once, we'll have to make it move forward, which means the background layer is moving. What's this said before? Not sure. Okay, folks, I think I will need help. Did I see a coin there? Yes, I saw a coin, but it's too quick to go away. I need the coin to stay for some time. So I need to add, okay, I got it. So apart from spawn delay, we also need to add a variable. Need to add random time for the coin to stay there. Random dot choice or wait, random dot random integer in the range I want my coin to stay for say 500 to, let's see what happens with this. There's the coin. Where is my coin? Okay, I saw a coin, but it did not stay there. Current time minus last spawn. Last spawn was 0. Let me say oh this 0. Can we please have a coin here? Okay, I did see a coin, but it did not stay for long. Again, I saw a coin. Where's a new coin? Hmm. Where are these coins going? The coin is rendered behind the trees. Don't call it inside the for loop. The coin is rendered behind the trees. I do not think so. I think it's a problem with. Hmm. Let me check my notes. Okay, 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 okay. So we have a list called coins list, and we haven't made use of it. Let's put it to use. All right. So once this is done, we use this coin and we add it to our coins list. Coins list dot append this particular coin. This is appended, and we add this. We will need this. Okay, anyway, once this is added to our coin list, okay, and let's go for coin in coin list coin dot draw and coin dot move. For coin, and we have coin dot move coin. Fine. So also once a coin gets out of the screen, we do not need to draw it. Okay, we have a coin spawned here. That was too fast. Okay. The coin is moving super fast. Yeah. Okay. The coins move at this speed. Fine. Let me reduce it to 500. Plus, we need to do something with the velocity of the coin. Hmm. Okay. Um, let's see. The coin is super fast. Let's call a variable called coin velocity. Let's keep it constant at say 5. And here coin velocity. Now let's call this Okay, still too fast. Too fast. Let's change coin velocity to, I guess, 1. Yay, we can see the coins. Okay, I think that spawned 2 above for our cattle to get to them. Let's spawn them somewhere near coin image dot get size. We could. Okay, instead of saying random choice between 200 to 50, start from 300 probably, go to 850, 750, 900. And for Y, I think they should be much lower. Our sprite position is 480. We need to keep it near our sprite. 450, 380, 480, 450, something 400. Let's see with this. Okay, why is it not? Why are all the coins up there? Something is off. Something is off. Right. Okay. So, if you notice, this is the same coin. Yep, it's the exact same coin coming at the same place. We need to do something. Okay. Let's go edit this. So once the coin is out of the screen, we need to delete it. Def delete coin or something like. I mean, okay. We need a property variable that says is off screen or is out of the screen. Fine. Property that tells us if the coin is out of the screen. Okay, and this will return if self.x is less than 0. I mean, return true. False. So if our x is negative, which is x has moved beyond our screen, like it has moved out of the screen, we return true. That means the coin is out of the screen. And here, if coin dot we can access the property is out. If coin is out, we can do coin. We can delete the coin. Coins dot coins list dot remove this particular coin. Okay? We do not want to go off the screen. Just so that our this thing gets rendered, and instead of placing this here, this is because issues, let's place this here. Okay, let's see. Something changes. These coins are I don't want the coin to move if I am not moving. I can take this away from here. And okay, or can I reduce the speed? Coin velocity to point three or point five. And I think this needs to be brought down still. And we're not giving it a random choice. Like 600, 650. Let's see. Yes, we have a coin. Okay, very cool. We have our coins and they're getting spawned. But we would want our cat to interact with them. How do I stop the coins from moving if my cat is not moving? Yes, definitely. Okay. I think we're very close to the end of the stream, and I think there's a lot to debug in this yet. But with what we have achieved in the last 2 hours, I think having this cute little cat game, um, yeah, I mean, it looks fine for just like 2 hours of sitting here and coding. So, well, I'll push this on GitHub. I'll push it on GitHub right now. What we can do is do a git init, git init, dot. Okay, let's go to GitHub. Let's create a new repository. Call it cat. And yeah, we create an empty repository, we push the code, copy the commands. Okay, sorry, I did not do git add, git commit. Well, very well. Let's refresh this. Perfect. I will share the link of this over here. Yep, the link is on the way. Let's spin this. And please feel free to contribute to this. I'll be more than happy to have this game actually running. And I'd love to see something happen with the coins. Like, oh my god, this is running in the air. I did not notice. This is super funny. But well, I'll just have this, like, I like this cat to consume these coins and do something with it and stop these coins from coming at the cat. So, if you all want to try your hands at this, please feel free to clone this repository and play with the code. Try changing values here and there. Try cleaning up the code because this is like super dirty. I mean, I would never write this kind of code like while building an actual project. But well, I had a lot of fun trying to build this. Let's end the stream now. Yep. So Yeah, cheers to me for not losing hope. I really enjoyed making this game. I really hope some of you will come up and try to recreate this. If you do tag me in the Discord channel. Drop your project link. Also, I just gave you a great project idea for your Global Hack Week submission. So if you do not have an idea yet, why not submit a Cato run, Doggo run, or Capybara run even? The capybara is trending these days. So, well, also do not forget to tag me on Twitter if you happen to try this game out, or if you happen to join the stream and just share with your friends that you're attending Global Hack Week today. And with that said, let's leave say 5 minutes for a bit more discussions or questions, or if anybody has anything to say. Yep, I will update the repo after this stream very soon. And this should be in working condition, something that you can play on your laptops when you're bored. Better than Chrome Dino. So, yeah. And we'll take a while to just let everybody sink in. Thank you for joining. Also, do not forget to check out the other technical streams that are there. Thank you so much, everyone. Thank you for coming here. Yep. Capybara bye. It was all my pleasure to have this session. Let's meet in more Global Hack Weeks soon to come. Okay, and with that, let's end the stream. Thank you for joining, everyone.